Welcome to the start of week 2. So we ended up last week talking about stacks. So a stack is a first in, last out structure. Okay. So what we're covering today is a queue, and a queue is just the opposite, right? A queue is going to be a first in, first out. Okay. So we think about this if you're in a line at the movie theater, okay, for example, then the first person in line should be the first person to get in, right? So with the queue, just like we've talked about before, we're going to have an interface, we're going to have an implementation. So for the queue in particular, we're going to have the following. Our ADT that we're going to develop. Okay. So we have our constructor, we have a destructor, and then we have the following functions. So, and these are sometimes called different things in different settings, but this is what we're going to go with. InQ takes an integer value and adds it to the queue. Okay. It adds at the back and pulls from the front. Okay. We have DQ, which will remove the front item, the one that's been there the longest. Okay. Um, we then have the front, which will return the element that's at the front without removing it. Okay. And then we have a back, so we can look at the back element. So unlike the stack, we can see both ends. Okay. And then we have an empty, or an is empty as it's sometimes called. And then we have a size. It returns the current size of how many elements that are in the queue. Okay. So that's the idea there. So we have multiple ways to implement this. We can implement it just like stacks with an array, or we can implement it with linked lists. Okay. So we're still talking about linked lists. We're not really covering them much in much detail until tomorrow. But for today, we're just going to go with the basic idea of a linked list. Okay. So a queue is fairly straightforward way to do this. Okay. But there's a problem we have to worry about, unlike with stacks. So let me switch here to the other. I've got a spreadsheet here that I've had AI create for me to explain this. Okay. Again, my spreadsheet's really ugly. So the idea here is, let me see if I can make this a little bit smaller, make it a little bigger for you. Okay. Hopefully that made sense. Okay. So we have this empty queue. Okay. So we have our positions 0 through 6. So this is a queue of 7 spots. Okay. We're going to over here in Q and A. So A is on there. We in Q a B, it's on to there. In QC, it goes to there. Life's good. But when we when we DQ, it's going to return that A, but now there's a hole here. Okay. So as we go on and DQ again, we get the B back. So now front and back both point to C. Now we can go ahead and add a D and an E and an F and a G. Okay. But now we're going to try to NQ one more. We should be able to because we've got 1, 2, 3, 4, 5 items and we want to add one more so it's not full, but it's out of space, right? We can't add any more to it. Okay. So that's the problem. So it reports it as being full, but it's not. There's 2 empty spaces. Okay. So the way we're going to fix this is with something called a circular array. So the way a circular array works, and again, all of this is in more detail in the tutorial. The circular array is going to use modulus mathematics. Okay. So mathematics divides and then returns the remainder. Okay. So we're going to set the index being equal to index plus 1 mod the capacity. Okay. So in the same thing here, okay, we keep moving along just like we did before. But once we get to the G, when we set the new one, okay, so it's going to be bigger than the capacity, it takes us back to 0. Okay. And then it can go from that way. Okay. So the front and the back get kind of twisted around as we go. Okay. So that's the circular queue. And let me go ahead and go back to the other document. There it is. Too much stuff open as usual. Okay, so that's the idea of the circular array then. Okay. So again, the basic idea there is that we're going to just set the tail equal to tail plus 1 mod capacity. Then that's on the NQing. When we DQ, the head will be equal to head plus 1 mod capacity. Same thing. We keep track of the head and the tail, where those locations are at. And then the full condition is if the size is equal to capacity, it's empty if the size is equal to zero. Okay. And here basically is how we would go about doing that with this array queue. Okay. You see, we've added the private data here for the head, which is the index of the front element, the tail, which is the index of the empty element, and then we have the size and the capacity there. Okay. And then here's a listing of what some of those methods would look like. Okay. Again, we're doing that modulus operator. Okay. And there'll be examples of that in the tutorial. Okay. And then with the linked list implementation, the advantage to the linked list, as the advantage to a linked list always is that it can grow as big as you want. When you're using an array, you have to determine how big it's going to be. Even if you use a dynamic array like a vector, you still have to decide at some point how big it's going to be. It can't just grow. A linked list can grow as much as you want. Okay. So one thing you see here on this code that it put into the example is this octothorpe pragma once. And when you do that, that's kind of the modern way. Before we talked about doing the if not defined guards, where you put that kind of stuff in. That's still used a lot. You'll see that a lot. But you can also do this pragma once, which does the same thing, which means only load this thing once. Okay. I think I've mentioned it before, but anytime you see the octothorpe or the hash symbol there, that's what's called a preprocessor directive. Okay. That means that it's going to happen before any other compiling starts to work. Okay. And for this one in the private, we're going to have our node again with our data, with our next. Okay. And the little constructor there. Okay. And then there are the key methods for that, where the enqueue, there's no need for the circular special stuff with an array, with a linked list, because a linked list you can add to the front, add to the end, remove from either end, doesn't matter. Okay. So that's just an idea of what some of those functions look like. Again, you'll see more in the tutorial. Okay. So just looking at the array version versus the linked list version, again, the real issue is the fixed capacity, okay, which is an important thing. Okay. Oh, one other thing I wanted to mention with the linked list. The linked list 100% will activate the rule of three, which means you have to have the constructor, sorry, the destructor, the copy constructor, and you have to override the assignment operator. Okay. It's also important when you delete an array, sorry, delete a queue, you have to go through and make sure you've deleted every node that's been allocated. You can't just delete the head node. Because if you just delete the head node, you still got these other nodes hanging out there. Okay. And we'll talk more about that concept more tomorrow when we get to linked lists in particular. Okay. So there's this other concept that we'll talk about later as well. It's a it's a DEQUEUE. It's pronounced deck. Okay, so the deck just gives you the ability to either add at the front or the back. Okay, so it's kind of like a stack and a queue combined together. Okay. Um, so as far as the lab goes for today, the lab six, within it, you're going to implement the circular array queue and then run the provided driver program. Okay. So the driver program is going to stress test this wrapping that you're going to go past the end and come back around. Okay. Which is important. Okay. Um, other than that, that should be it for now. So hopefully you're keeping up. Again, the class happens quick. If you have questions, make sure you let me know as soon as possible so we can get you back on the right track.